Let's take a look at these two examples. I have to find the frequency first. Frequency is equal omega over 2 pi. My omega is 4,500 radians per second over 2 pi radians. Remember, anytime you don't see radian, there is always invisible radian. I just made this visible. Radian and radian will cancel out, and I'm going to get 716.19 hertz. Please keep in mind that you're supposed to put the parentheses anytime you will try to enter this expression into the calculator. Period is equal 1 divided by frequency. 1 divided by my frequency is 716.19 hertz. This is equal 1.396 milliseconds. And these are the solutions to my problem. Let's take a look at this example. Very first thing which I'm going to do, I'm going to reduce the fraction first. 2 and 64, both of them are divisible by 2. So this is equivalent to 1 over 32 radians per second. Frequency is equal omega over 2 pi. Because my omega is expressed in terms of fraction, I'm going to write this expression in the way how you're supposed to enter this into the calculator. So simply 1 divided by 32, and this is of course radians per second. Fraction bar represents the division, so that's why I'm going to divide by, open parenthesis, 2 pi. And your answer is supposed to be 4.97 times 10 to negative 3 hertz. Please notice that we do not write any prefix next to hertz for the frequency, which is lower than 1 kilohertz. We simply write the powers of 10. And of course, anytime I do not write radians next to pi, there is always invisible radian. Radian and radian will cancel out, and you will end up with the unit 1 over second. 1 over second is 1 hertz. That's why I got hertz over here. And this is my frequency. This time I have to find the period. Period is equal 1 over f, which is equal 1 divided by 4.97 times 10 to negative 3 hertz is equal 201.2 seconds. 201.2 seconds. Remember, second is 1 by hertz. 1 divided by hertz gives me seconds, and this is the time for this omega.